Today we're going to begin topic 4, scientific notation. The first lesson is 4-1, exploring scientific notation. Some of you probably remember having been exposed to this last year. If you read just what's on the screen, some numbers are so large, others are so incredibly small that they're difficult to write. So we use scientific notation to express these numbers so that they're not only easy to write, but so that they can be compared. A number in scientific notation is written as the product, multiplication, of two factors. One factor, which is in yellow, is greater than or equal to 1, and it also has to be less than 10. The other factor, which is in green, is a power of 10. The example here is 2 3400 times 10 to the 5th power. The example on the next page, 6 9200 times 10 to the 5th power. In blue, the first factor is greater than or equal to 1, and it's less than 10. The exponent, 5, is an integer. This is in scientific notation. To write this in standard form, you are basically being asked what was the number before you put it into scientific notation. The exponent of 5 tells us how many places the decimal was moved, and the decimal right now is between the 6 and the 9200s. To put it back before it was in scientific notation, we move it back to the right 5 decimal places. The number prior to scientific notation, we called standard form, is 692,000. You probably already have a good idea as to what the answer to this focus question is. Why might you use powers of 10 to write numbers? So just jot that down. Towards the middle of your page, you see 8 boxes, 8 lines, and it says order or rank the tiles from least to greatest numeric value. Explain how you know your order is correct. There are 4 boxes that are in scientific notation. There are 4 boxes in standard form. Before you rank these, either put them all in standard form or put them all in scientific notation. We'll come back in 30 seconds. If you took the numbers that were in scientific notation and put them into standard form, you would find that 2 of these boxes obviously are 30, 2 are 300, 2 are 3,000, and 2 are 30,000. If you change them into scientific notation, you found that you had 2 at 3 times 10 to the first, 2 at 3 times 10 to the second, 2 at 3 times 10 to the third, and 2 at 3 times 10 to the fourth. Take a quick look at this table. First column is a number, followed by powers of 10, followed by the exponent. Taking the number 5,000 in standard form, putting it into scientific notation would require us to put the decimal between the first 0 and the 5. That's moving the decimal 3 places. Going down the number column, when we get to 5, please notice that the power is 0, and you already know that anything to the 0 power is 1. As we get into the decimal places, just like you've just finished going through, we are in negative exponents. On your sheet, you have a table similar to the one we just looked at. It says, look for patterns in the table, decide whether each statement is true or false. As the exponent of 10 increases, the number becomes greater. Is that true or false? As the exponent of 10 increases, the number becomes greater. True. A negative exponent of 10 makes the number negative. And you know that that's false because a negative exponent means a number between 0 and 1. Letter C, 5 times 10 to the third is greater than 5 times 10 to the second. That is a true statement. Letter D, 5 times 10 to the negative third is greater than 5 times 10 to the negative second. That is false. Order the following numbers from least to greatest. 2 and 34 hundredths times 10 to the second power, 2 and 34 hundredths times 10 to the negative 2 power, and 2 and 34 hundredths. Which of these do you believe is the smallest one? If you said number 2, you were correct, because that is a number between 0 and 1. If you said the next smallest was 2 and 34 hundredths, number 3, you were also correct. And the largest of the three is 2 and 34 hundredths times 10 to the second power. Take a look at this example. Circle the numbers that are expressed in scientific notation. For the numbers not circled, explain why each is not expressed in scientific notation. 20 times 10 to the third, yes it is. 4 times 10 to the negative third, yes it is. 4 and 22 hundredths is not in scientific notation. 10 times 10 to the sixth power is also not in scientific notation, because the first number, your first factor, has to be less than 10. The next one at the top of the next column, 5 times 2 to the 10th power, is not in scientific notation. That 2 should be a 10. 2 and 7/10 times 10 to the 120th power. Yes, it is in scientific notation. 7.5 times 10 to the 0 power is, yes, also in scientific notation. 0 and 5/10 is not in scientific notation, because 5/10 is not between 1 and 9. Another example here, which of the following numbers are not expressed in scientific notation? The first one, yes or no? Yes, it is. The second one, 27 and 3/10, is not in scientific notation. 8 and 4 hundredths is in scientific notation, times 10 to the negative 2 power. So the only one that of these three that is not in scientific notation is the middle one, number 2. Some of you may have already seen this. If you take two really large numbers and you multiply them, like 800,000 times 7 million, most calculator displays do not have enough space to show many digits. So when you put in that 800,000 times 7 million and you got 5.6e plus 12, you can interpret this as scientific notation. The plus sign means exponent of 10 is positive. That exponent of 10 is 12. 5.6 is in scientific notation. So we have 5.6 times 10 to the 12th power is how you would read that number. I have copied a few of the problems from your student companion onto this sheet. I would like for you to complete problems 1 to 5 as part of your homework and bring it with you to class tomorrow. Thank you.